Left off. So, none of this was on the quiz, but we started it last week. Remember, we started looking at equations like 5c.
So what page are we on?
26, right where we left off. And your job is to find all of the zeros. So we're not actually sketching this, but remember the zeros are these points right here. We're going to find those points. Now how are we going to do that? We're going to try to factor. Would you agree with me? But factoring by grouping isn't going to work.
Gotta divide.
Would you agree with that?
Or do you go?
So we're going to start guessing and dividing?
Yeah.
Who remembers how we build a pool of possible guesses?
The last number.
So my PRRs are going to be factors of 8
Is this the rational function?
over factors of 1. No, this is a polynomial function. Now, I would, if I had a rational function, I would factor it also, but this is a polynomial. So I want possible rational roots. Here they are. So pick one.
4.
4. Oh my gosh. Oh my gosh.
I'm in. My lordy.
Now, I did not think 4 was going to work, so I was fully prepared to ask for another guess, but it worked. So now what does that mean? That means your job was to find the zeros. So one of your zeros is x equals 4. Now, there's gonna be 4 of them because this is a x to the 4th. And if you think about in its factored form, wouldn't there have to be 4 x's, 4 parentheses? So there are gonna be 4 answers. You now have 1 of them. Okay? Now, what's left here? What does this stand for?
X to the third.
X to the 3rd,
And we got 1 is
x squared,
and then minus 2x.
minus 2.
And it's
Now we can group. Everybody see that? Now what if I couldn't group, or what if I just don't want to group? Then I will guess again. And now into this number. This is where I would be guessing now. I'm done with that original. Now I'm here. And my PRRs would be only factors of 2. But Elijah noticed this grouped. I hope you did too. We can take an x squared out of the first 2. And a negative 2 out of the second 2. See how that worked? So I've got x plus 1 and x squared minus 2. Now again, our job is to find what does x equal. So this one's easy. X equals, not 1, negative 1, negative 1. And then x squared minus 2, if I solve that, x equals plus or minus root 2. So there are my 4 answers. Alright, so let's back up. That's a big problem. We did lots of stuff. First thing we did was figure out what the PRRs were and start guessing. And we got really lucky. Somebody said 4. It worked. Good. That's one of our answers. Then we took what was left and we noticed that it grouped. So we grouped it. And that brought us to here. So we knew one of our answers was going to be negative 1 and the other one, other 2, plus or minus 2. that ringing some bells? Remember doing that stuff? Okay. Now, for problem 6, show that 3 is an upper bound of this polynomial. Now, what that means is, if 3 is an upper bound, then there are no numbers bigger than 3 that will divide in evenly. Okay, so let me go back, I just erased it. But remember when we had these were our possible rational roots? If I had a different problem and I figured out that 3 was an upper bound, then that would automatically mean those couldn't possibly be answers. At least the positive ones, the negative ones, not the positive ones. Because if you're an upper bound, that means there's no answers bigger than you. All right, so how do I know it's an upper bound? Well, it's really easy. Do the division. Do the division.
If it doesn't go into this number.
No. Yeah, I mean, 3 is not a 0. How do I know 3 is not a 0? I didn't get 0, right? I got 19. Let me double check. Are my numbers all good? Now, do you notice how everything in this bottom row is a positive? When that happens, you have an upper bound. So when you do the division, and you get this all the way across, that means there are no numbers bigger than 3 for you to try. So if your PRRs had included, 6, couldn't do it. No number bigger than 3 is gonna work. 3 doesn't work, but no number bigger than 3 will work.
So that would just be like that.
This would show it's an upper bound because all of these numbers in the quotient are positive. When that happens, it's an upper bound.
What?
Now, look at the next one, it says, this is a lower bound. I'll do the division and see what happens this time.
Y'all should be hating.
No, good guess though. Let's see what happens.
Alright.
Oh, check my arithmetic here. Okay. What is that, 50? Now it's 47. It's gonna be some negative thing, it's gonna be some negative thing there. So what happened? Every other. When the signs of the quotient remainder here, this sign right here, your answer will, when the signs alternate like that, that means you have found a lower bound. Okay? So I can see a test question, is 6 an upper bound? What are you gonna do? Divide 6 in, and if it turns out all positive, it's an upper bound. If it turns out alternating like this one, it's a lower bound. Now again, what does that mean? That means if you're in a situation where you're guessing numbers, don't guess anything less than -4. It's not gonna work. Okay, Ronan?
So once we get our first negative and then upper bound, that means
You're done. Alright, so everybody clear about that? You kind of just have to memorize those rules. It's a synthetic division problem. All positive means you got an upper bound, alternating means you have a lower bound.
Can it alternate both ways?
Yep.
Negative
Who cares? You're enjoying every minute. Stop it. Alright, 2.5. So 2.4 will be due on Oh, shoot,
Next
Monday.
week.
Yeah, Monday, a week from today. All right, so here we go. Use the given zeros to find the other zeros of the polynomial. How many zeros does this polynomial have?
3.
3. They're telling me ahead of time, they're just saying one of your answers is 2. And then my job is to find the other 2. There's 2 more, and I have to find them. Okay? So what do you think?
Take 6.
I could, but it's actually gonna be easier than that.
Then
London?
you just put in the 2 and then divide it to find the other one.
So she says, look, 2 is a root. What's gonna happen when I do this division?
No.
I'm gonna get another remainder if I've done it right. What's gonna be left?
Problem.
That I can factor to get my other 2. So yeah, thank you, London, that's exactly what I want to do. I want to divide out the one I know. They tell me it divides in, so I'm gonna divide it, get rid of it. And then what I'll have left is x squared minus 4x plus 3, which factors as x
Plus 3. Minus 3.
minus 3 minus 1, which means what will be my other 2 answers?
3 and 1.
3 and 1. Wasn't that easy?
Very.
Very easy. Very easy.
Wait, why didn't we, wouldn't number 1 be x cubed?
Wouldn't what now?
Number 1, like wouldn't the 1 be x cubed?
No, no.
No, you
Drop.
When you divide, the power goes down by 1.
Oh,
You're dividing out an x. So obviously, if you start with x cubed, you're gonna be down to x squared. All right, that wasn't too bad. This next one though is a little bit crazy. What? Now, they're telling me, Dina,
why do you have asterisks on it?
they're telling me that one of my roots is 1 plus I. Now, a piece of information that I haven't shared with you, but you might remember from last year is that imaginary roots, this is an imaginary number, right? It's got an I in it. Imaginary roots always come in pairs. They always come with their conjugate. If you think about when you were like solving stuff with the quadratic formula, didn't you always get things like -3 plus or minus I root 7 over 6? I mean, it always was plus or minus I stuff. They always come together. So if we know that 1 plus I is a root, then we automatically know that 1 minus I is a root. Those always come together. Okay? So if you know one, you automatically know the other one. So there's 2 more out there that we need to find. This is a harder version of London's problem. London said, hey, you know a root? Divide it out. Well, this is a little bit harder because the root is imaginary. You can actually do synthetic division with imaginary numbers. But it is a little bit complicated, so we're not gonna do it that way, although you are welcome to. You can divide this one out and then divide this one out. Instead, what I'm going to do is this. I'm going to take these two givens. And I'm going to move them over, set them equal to 0. Like that, I'm gonna have it set equal to 0. So move the 1 over, move the I over, move the 1 over, move the I over. So everybody okay with that? Then I'm gonna take these two things and I'm gonna multiply them times each other. Before you start freaking out, this is just going to be a big foil. Right? So, one term at a time, here we go. My own personal preference is I like to take this guy right here times all 3 of those. So x times x, x times -1, and x times I. Let me distribute. Then I'll do the same thing here. So I'm going to take -1 times x, -1 times -1, and -1 times I. Everybody following along?
Yeah.
Tedious, but not hard. And then same thing here. So negative, positive I, and minus I squared.
R squared is -1. Just so
Okay, so that
A
makes
one,
a +1 on the end. Did you notice anything else?
They combine I, so just cancel out.
These are gone, right? They cancel.
And then you combine the I of x's so they cancel out.
Those cancel. Wow, awesome.
And
X squared,
Minus x plus b.
actually minus 2x,
2x.
plus 2.
I wouldn't do that.
And because these will always be conjugates, you'll always cancel a whole bunch of stuff.
And then you solve it.
No, don't solve that.
Oh,
If
no,
you
no,
solve
don't solve
that,
it.
you're gonna get what you already
Don't
had.
solve it, but get the
Now we're gonna take that,
factor it
no,
in.
You don't, you can't.
Guys,
You get the same.
that just brings us back to what we started with here.
You're
We're
dividing.
gonna take this and divide it into this. Oh, stop it, this is not bad at all.
This is really hard.
No,
Busy.
it's a lot.
Busy fail.
Alright, so here we go.
Wait, is this
X squared goes into x to the 4th how many times? X squared. Or think of it like this. What do I take times x squared to get x to the 4th? X squared. X squared times x squared is x to the 4th. That's what you want to have happen. You want to get x to the 4th. Then x squared times -2x and x squared times 2. Oops, minus plus 2. X squared. Alright, so I took x squared times that, x squared times that, x squared times that. Now I'll subtract. Oh wow, both of those go away. So I have -3x squared plus 6x minus 6. Bring these down. Start over. What do I have to put up here? So when I times it times x squared, I get -3x squared. Minus 3. Now remember, you have to subtract, so you're gonna change the signs, and what happens? And I knew that would happen because these were factors, right? Now, what's left is x squared minus 3. Can you solve that? plus or minus
Square root of 3.
square root of 3. And those are your other two answers. Now, I agree with you, that is a big problem, but it is not unmanageable. Lots of steps. So let's go back through the steps again. Once they gave me this one, I knew that one. So what did I do next? I set them equal to 0 and then multiply them together doing a giant foiling. Then I took the answer that I got and divided it into the original. And then I solved what was left. Simple enough. So simple, in fact, Charles. Hurry, do it again. Look at problem C.
Yeah.
Yes. I love
Now,
it.
problem C would be easier because it's just 4i. But there's a little asterisk there. Take a good look at this problem. Forget the 4i for a second. Does anyone notice anything about this problem? It factors. It actually factors. If you notice, you don't have to do anything. You can just factor it. If you notice, what are some factors of
6 and 8. 6 and 8, 12, 4.
6 and
48,
8,
1,
12, 4.
24, 2.
2 and 24.
6 and
We already said it, we already said that.
How about 16 and
3.
3? That sounds like a winner.
Sorry. And then you do X.
So then x squared equals 3, or x squared equals negative 16. Now that's where the 4i came from. They told me 4i was going to be one of the answers. I automatically knew then negative 4i would be one. But without doing all that work I did last time, I can see that my other two answers are plus or minus root 3. Because I had my eyes open and I noticed it factors. Factoring is always going to be easier. If you can factor, do it. You don't have to, but it's just faster.
Make a good sound.
Okay? All right. Number 2. Write the polynomial function with these zeros. So x equals 2, x equals I, x equals negative I. Remember, they never come alone. I's never come alone. So if I is a root, negative I is a root. What are factors? What factor is this?
X
X
minus 2.
minus 2,
X
X
minus
minus I,
I. X plus
X plus I. Would everyone agree with that?
You gotta now like foil.
Let's foil these two first. That'll be easier because stuff will cancel.
X squared
X squared
plus IX
plus IX
minus IX
minus IX.
plus 1
Yeah, minus I squared, which is going to become
plus
plus 1. All right, everybody keeping up? We wrote all these as factors. We foiled those. I squared is negative 1, so that became a plus 1. And now we'll foil one more time. There we go. There's our polynomial.
Oh, that's all, that's it?
Huh?
That's it?
No,
Oh. X.
no. What's missing? Back here in the factored form, there was an N missing out there in front of the factors and multiplier,
Oh.
right?
Yeah.
So I need to find that N, so I'm gonna hold off on this, I'm just looking at this for now.
We're getting the
Who
X and Y.
remembers how I do that?
Play the X and Y.
So
The points.
8 equals N times -1 minus 2, and 1 plus 1, because that's -1 squared. So you put in 8 for Y and -1 for the X's. So that is gonna turn out to be what?
N
What is that?
8.
8 equals -6N. Did you get -4/3?
Oh, yeah.
Now, the directions say multiply out. No, you already did. You already did, right here, right? You already multiplied out. The only thing we didn't do is multiply through the -4/3. So this is gonna be -4/3. Now I gotta take it times -2. So what's -4/3 times -2?
Negative 8/3. No, 8/3. 8/3.
8/3. And then here just -4/3. And this one's gonna be plus 8/3. Oh, no, there's no end. No, that one just stays. What was that? -2, that one just stays. There's no, oh no, I gotta multiply that. So plus 8/3. So, once you figure that out, just distribute it across the whole polynomial, and that will be your answer.
And what's like a real world situation where
Where what now?
a real world situation where I need to know this
Where
equation?
you- oh, I don't know. I mean, you have to be able to, well, in math class, you have to be able to build equations from data, and the data was zeros. You could, there could be situations where you have data points and you want to build an equation to predict what will happen with other data points. It's called regression, but chances are you won't be doing it by hand. You'll be doing it here, or computer, yeah.
If you get that important.
But you know what? I could say the same thing, Dana. When I go in to the weight room, I mean, quite honestly, I'm 65 years old. Do I really need to do burpees? Is there a reason for me to do burpees? No, not, I mean, I can be a perfectly fine math teacher without doing burpees. Why do I do it? To keep this strong. Why are you doing math? To keep this strong.
That does make sense.
That's a big quote. That's a big quote.
Yeah. All right. B is gonna be a big one. Let me see how much time we have left.
We're getting close to time. I don't know if we have time.
Charlie, I don't believe a word you said.
Him. It was
All right.
him. We don't have
Here we go. We're not gonna get it done, I just wanna get it set up and we'll pick up here tomorrow.
Turn it off.
We have a polynomial function with zeros at 1 plus 2i.
And 1 minus 2i.
Exactly. So I have another one at 1 minus 2i. No. What am I going to multiply together?
1 plus 2i, 1 minus 2i.
Be careful, no.
Oh, wait.
X minus
Oh.
1,
X plus.
Minus.
X, set it equal to 0.
X minus 1, X minus 2i.
X minus 1 minus 2i, X
Minus 1
minus
plus
1
1.
plus 2i. That's where we'll end today. We will start there tomorrow with a bunch of multiplying.
Like a lot. Yeah, we did. It is satisfying.
Bring the wax, bring the project to be said. All right? Was it very kind?
Some of the dogs get the body.
It's a lot more safe.
I'm worried about it.